Turbomachine, centrifugal pumps. Turbomachines are the commonly employed device that either supply or extract energy from a flowing fluid by means of rotating propellers or vanes. Pumps add energy to a system with the result that the pressure is increased. It also causes flow to occur or it increases the rate of flow. And then turbine will extract energy from a system and convert it to some other useful form, typically to electric power. Hydroturbine is a machine that generates power from high pressure water. Relatively large conduits or tunnel deliver fluid to closed turbine in order to generate power. Another example is steam turbine and air turbine. So here in this chapter we will learn about pump and turbines. There are two types of turbomachines. One is pump and one is turbine. As I described previously, pump is a machine that add energy to a system. However, turbine is a machine that extract energy from a system. This is the difference between turbine and pumps. And here I would like to show you a pump classification, because in this chapter we will focus on pump first. We have pump here, and pump could be divided generally into two major groups. One is rotodynamic. Here we only write as a rotodynamic pump, and a positive displacement pump. And in rotodynamic pump, we could divide into two majors. One is centrifugal and one is the special effect pumps. In positive displacement, we have one reciprocating and one is rotary. So in centrifugal here, we have three basic pump, which is axial flow, mixed flow, and the peripherals. In special effect, we have jet, electromagnetic. In positive displacement, in reciprocating pump, we have piston and plunger and diaphragm. And in rotary pump, we have a single rotor and we have a multiple rotor. So what is the difference between rotodynamics and positive displacement? First, we need to understand what is pump. Pump is one device that could add energy to the system. However, in rotodynamic, they use kinetic energy, means the moving blade, to transfer kinetic energy from the device or from the blades to the fluid. And positive displacement here means they transfer fluid by the idea of move the volume. I will show you later in the diagram to make your understanding easier. So we will learn about pumps here for only rotodynamics for centrifugal pump only. So we are focusing on peripheral or normal centrifugal pumps. So in dynamic pump means in centrifugal pump we have three major pump, which is axial pump, radial pump, and mixed pump. So in axial pump, the difference is why we call this an axial pump, because we absorb flow and the output flow here is still remain direct with will have a same direction with the inlet. So we could see if the water flow at the inside is from left to right, and at the outlet it also flow from left to right. So it is an axial flow. So the radial flow means that inside the pump, the suction here, it will flow from left to right, horizontal. However, at the output here, the flow is vertical, means that it's changed from the horizontal flow to the radial flow here inside the blade of pump here. So we call this pump as a radial flow pump. So and then this is the mix, because it is not 90 degree here, it's slanted at certain angle, might be 45 degree here, so it is mixed between the axial and the radial pump. So we will focus on the radial pump. It is a normal mechanism for centrifugal pump. And this is the example for positive displacement, means we transfer the volume of fluid. The simple example for positive displacement pump is the piston pump like this. So I think you could imagine if we have a piston pump like this. When we move this piston, when we move it upward, so it will suck water from bottom into this compartment. At the same time, at the upper compartment here, it will compress the water, and the water will flow to the output here, and then the water will flow. It means that this is still a pump, means we give more energy to water at the low level here, and it can be transferred to the upper level at C here. And this is the positive displacement, still a pump that used the idea to transfer volume of fluid. However, it still have a rotation motion here, movement here. So we call this lobe pump as rotary pump, means we have a mechanism rotate at certain speed. However, this rotational not transfer the kinetic energy, but it create a volume, for example, of water flow from left to right here to this inlet. So the water will stay in this volume, and then when this lobe rotate, so the volume here will transfer to from the left to the right here, and the volume of water will flow out at the outlet here. So this is the idea, not to use the kinetic energy, but to use but we use the volume of fluid to be transferred from time to time. And then I would like to remind you about the Bernoulli equation, because we will use Bernoulli equation in this chapter. So this is the very basic Bernoulli equation. We have P over G, V squared over 2G and Z. P is the pressure, V is the velocity, and Z is the potential energy or the elevation of water. And subscript 1 means the inlet, and subscript 2 here is the outlet. So I think you still remember how to write Bernoulli equation. And then if we have pump in our system, we need to add HP, mean head of pump. This shows the energy added by the pump in the total amount of energy at the inlet. And if you have turbine, we need to add turbine at the output, because turbine is a machine that absorb energy, so it must locate in the output here. And then please make a revision about major loss and minor loss, because in our Bernoulli equation here, we need to add with total losses, include of major loss and minor loss. So the usage of pump can be divided into two major usage. Means one is to increase the amount of energy in the system. Then when the fluid here has higher energy, it could move from lower level to the upper level here. Or we give more energy to the fluid here, and then fluid could travel, could move, or could flow in higher speed. So we could have this one. This is a workpiece cutter, but the medium is not a jigsaw, but a water jet. So I hope you could you know about we could cut metal by using the water jet here. So we need to give more energy to the water jet here, and to make sure it could flow at the higher rate. Okay, so we enter the about centrifugal pump. So a centrifugal pump consists of two principal parts. one is impeller here, which impart a rotary motion of the fluid, and then we have a housing or casing here. So this is the housing, which direct the liquid into the impeller region and transport it away under a high pressure. So the mechanism of centrifugal pump is like this. The water will flow into the inlet to the center of the impeller here. So we call this inlet area is an eye. It's located in the middle of the impeller. So what is impeller? Impeller is a set of blades. So please imagine this is one blade, for example. To be simple here, this is a blade of a pump, and the whole system of this blade can be named as impeller. And this impeller is covered by a shroud here. So we have the top front shroud and the back shroud here. Okay. So the idea is the water will enter from the eye here at the center of the impeller, and then the water will move with blade. As you know, blade will rotate at certain speed, so means blade, and then water come from eyes into the blades here, and then what happened here, blades move with certain amount of kinetic energy. Then the kinetic energy from the blades here will transfer to the fluid, to the liquid here, and now liquid receive the energy, means liquid has an extra energy. Because it has an extra energy, it could move to the upper level. So means, and then about the casing here. So the casing here must be waterproof, means we cannot have a hole or a leakage in the casing, because the pressure is very important in this mechanism. If we have a leakage, means that our pressure will reduce instantly, so the water cannot be transferred from lower to the upper level. So if you see the casing here, you will find that the cross-section area at the inlet here, you could see here the water is flow from the eye, and then it will flow here and then turn around until it comes out at the outlet here. So you could see that the cross section here is smaller compared to here, and the cross section will become increase its area a little bit to until at the outlet here, at the outlet area here. So it is purposely designed like this because, as you know, at small cross-section area here, if the flow rate is constant. Okay, let's say there are no leakage, means the flow rate is constant. So at very small cross-section here, the velocity is high. Then the pressure is low. Then at the big cross-section here, the velocity will reduce and the pressure will increase. That's the idea of Bernoulli. So the higher pressure at this area could push or could help this liquid to transfer from the lower level to the upper level. So the idea of this one, we call it the volute here, is purposely designed to have a small cross-section area at the inlet and larger cross-section area at the outlet. So now as you see, the direction of inlet is horizontal. However, the direction of outlet is vertical. So means that this flow is a radial flow. The impeller is mounted on a shaft and is often driven by an electric motor. The casing includes the suction and discharge nozzle and houses the impeller assembly. The portion of the casing surrounding the impeller is termed the volute. Liquid enters through the suction nozzle to the impeller eye and travels along the shaft, developing a rotary motion due to the impeller vanes. Volute casing peripherally at a higher pressure through the discharging nozzle. Some single suction impellers are open with the front shroud removed. Double suction impellers have liquid entering from both sides. So this is the basic diagram of shape of blades to create radial flow or to create mixed flow or to create axial flow. So the blades here will attach to the shaft here, and when shaft rotates at certain speed, the blade also rotates at the same speed. So to see, to have a clear vision about shroud, so we could see here, so this is shroud here, and here is this is the blade. So if you have see this is a blade here, but it's covers, we have covers here at the front and we covers at the back, so we call this is a shroud. This is might be a clear pictures of shroud. We have a front shroud here, we have a back shroud, and we have vane. Certain people says it is vane, certain people it is a blade, and then the set of blade here is called an impeller. So this is an impeller eyes where the water comes in. And this is the example of real centrifugal pump. So we have a motor here. The motor will plug in into the electric currents and it will rotate the shaft, and the shaft will rotate the vane or the impeller inside this casing. And then it's this inlet means the eye of the blade, the inlet of the eye of the impeller is connected with the pipe, and this is the outlet, it also connected to the pipe. And as you know that the casing here is very important. We cannot have any leakage of the casing here, because it will create the pressure loss. So if we lost the pressure, means that the idea to have high pressure at the outlet here to make sure that water can move to the higher level will be ruined.